Now, usually a complex number has a real portion and an imaginary portion. Now, when you have a number like 3 plus 2i or 2j, whatever you want to use, we use j in this class. Why? Because I represent what? Current. So j is the square root of -1. When you graph that, usually the x-axis represent the real values and the y-axis are the imaginary values. So that's a vector that's 3 units long in this direction and 2 units up. So that's what 3 plus 2j is. You made it?
Finally.
Okay. So that's the 3 plus 2j. Again, we can find the angle, because we know that's 3, that's 2. We can find the angle. You'll see that when we get to power and complex power, that becomes really important. But nothing more than math. You can find the x component. If you know this, you know the angle. You can find the y component. Sometimes we write these actually in polar. And in polar, to change that to polar, the magnitude of that will be the square root of the real portion squared plus the imaginary portion squared. So that will be what? 3 squared plus 2 squared, that's 9, 4, which is what, 13? And the angle theta, remember, this is 2 here and this is 3. That's the tangent, right? So it's the inverse tangent of the imaginary divided by the real. So it's the inverse tangent, in this case, of 2 divided by 3. And if I go to my cheap calculator for that, second tangent, where is it? Second tangent, 2 divided by 3. And that would be 33.7 degrees. The only time we're going to do something to this, and that's if this vector either in the second or third quadrant. Because if it's in second or third quadrant, the machine doesn't know where the minus sign coming from. We'll give you, if it's in the third quadrant, both of these numbers will be negative. Negative over negative is positive. We'll give you an answer in the first quadrant. It's supposed to be in this one. Or if it's in this one, it doesn't know if the minus sign coming from the x value or the y value, so it always gives you an answer in the fourth quadrant. So if you are in the second or third quadrant, you need to add 180 degrees if in second or third quadrant. Because the calculator doesn't know that. You add 180 to the answer here. So again, this vector, if you don't want to write that in rectangular, you can write it in polar. You can say we have a vector, it's the same vector, that has a magnitude of the square root of 13, and it has an angle of 33.7. We love polar. When you're multiplying and dividing complex numbers, polars are the best way to do it. Much faster and easier. But if you do a rectangle, it's not.
We're just looking to see if everybody's stuff is all set. Yours is all set.
Oh, yeah.
He's under some out anyway. Oh, that's right.
That's it.
You're like the other people.
No, see, we have a good dean. Now, how do we add, subtract, multiply, and divide complex numbers? I'll do them actually in rectangular, then I'll do them in polar. Addition, subtraction, polar is horrible. You don't want to do that in polar. It doesn't add and subtract in polar. You can't. You got to change them to rectangular. But in rectangular here, that means A plus JB. How do we add? How do we subtract? Let's look at addition. If I have 3 plus 2J, and I want to add to it 5 minus 4J. Just like doing plain algebra. You adding these together, because they're like terms. 3 plus 5 is what? 8. What's plus 2 minus 4? Negative 2J. You add the real to the real, the imaginary to the imaginary. How do you subtract? Again, it's the same thing. 5 minus 4J, and I want to subtract from it 3 minus 3J. What is 5 minus the 3?
2.
What is it? 2, yep. What's negative 4J minus a minus? Minus a minus is what? Plus. Negative 4J plus 3J is what? Negative 1J. Multiply. Let's see how we multiply complex numbers. 8 minus 6J times 3 plus 2J. This one, you're going to use the FOIL method. You're multiplying two binomials, basically. 8 times 3, 24, plus what? 16J, minus 18J, minus what? 12J squared. Remember what J is. J is the square root of negative 1. So what do you think J squared is? Negative 1. So since J squared is negative 1, it's going to make this one what? That's actually plus 12. So if we combine like terms, 24 plus 12, which is what? 36. 16 minus 18, negative 2J. And dividing, like 4 plus 3J over 2 minus 5J. How do we divide complex numbers? Anyone remember?
Reciprocal and then.
What do you mean reciprocal?
Oh, is it the conjugate?
Yes, the conjugate. Because remember, J is the square root of negative 1, so you have a square root in the bottom. And to get rid of the square root, multiply by the conjugate. So here we multiply by the complex conjugate, because these are complex numbers. What's the complex conjugate? You switch that sign. 2 plus 5J. 2 plus 5J. That's the complex conjugate. And now let's multiply them out. Let's do the FOIL on the top, the FOIL on the bottom. 4 times 2, 8. 4 times 5J, 20J, right? 3J times 2, 6J. 3J times 5J, 15j squared. Bottom, 2 times 2, 4, 10j, minus 5j times 2 is what? Negative 10j. Negative 5 times a 5 is negative 25j squared. Again, j squared is a minus 1. What's 8 minus 15? Negative 7. What's 20 plus 6? 26j. The bottom, notice that 10j and minus 10j will happen what? What will happen to them? Cancel out. This becomes 25. 25 and 4 is what?
Negative 21.
How about positive 25? Because the j squared is negative 1. That'd be a plus 25, and 4, that's 29. So if you want to write that as a complex number, you go, well, that's negative 7 over 29 plus 26 over 29j. Some people write the j at the beginning, some people at the end. It doesn't really matter. And if you have a calculator, you can divide them and get them in decimal. The problem is, like, we don't like to divide and multiply. That's a lot of work. So a lot of times when we have multiplication and division, we switch them to polar and we do them in polar. But you got to turn the numbers to polar. Now again, let's look at polar. How do we add in polar? Let's say we have 3 angle 30. You want to add to it 5 angle negative 60.
Do compound?
Yes. So here's what we have, just so you get to see it. If you took physics, you know exactly what we're talking about. You're adding vectors in physics. We used to take each vector, break it down to x and y component. So the 5 angle 30 is a vector that looks like this. It has a value of, 3, not 5. 3 angle 30. That's one vector. And the other one, 5 angle negative 60, is a vector like this. So what you have to do is find the x and y component for each one. And the x component for this vector is what? That's the x component this way. That's 3 cosine of 30 plus the j component that's up and down, which is what? 3 sine of 30. You want to add to it this one. Let's find the x and y component. That's 5 cosine negative 60 plus j 5 sine negative 60. So you can see adding in polar is really not a good idea. 3 cosine 30 is 2.6 plus j, sine of 30 is a half, that's 1.5. Cosine of negative 60, I think that's a 3. I think that's 2.5 here, right? This will be a minus j, 5 sine of 60, or negative 60. Negative 4.3. (2.6 plus 2.5 is what?
5.1.
5.1. And subtract 1.5 from 4.3. It's negative 2.8j. In that method, the same for subtractions. If you were to subtract in polar, you still want to do the same thing. So to subtract is the same process. It's the same process. You got to find the rectangular values and add them or subtract them. But what's nice about polar is the multiplication divisions. When you multiply, like 5 angle 30, and you want to multiply that by 9 angle 60. We multiply the 5 times 9. 5 times 9, which is what? 45. And we add the angles. 30 plus 60, which is what? 90. That's how you multiply in polar. Multiply the numbers in the front, add the angles. Usually you don't see negative values here in polar. Negative 2 times 4, which is what? Negative 8. Angle, what's 30 minus 20? 10. I said usually you don't see a negative number. Why? Because that negative number, it's really 180 degrees. So you can either add 180 or subtract 180 from that. So a lot of times when you have a minus sign in the front, you can either add, get rid of the minus sign, and just either add or subtract. It's up to you. Won't make a difference. 180 degrees. So if I was doing this, I probably would say 8 angle negative 170. Or 8 angle what? 190 degrees. I probably use this to try to keep the angle under 180 degrees. But it doesn't really matter. So that's why a lot of times you don't see a negative value. A negative is always a phase shift of 180 degrees. Either add or subtract 180 degrees to your answer. Now when you divide, it's even better. Well, it's not better, the same thing. So you can see division, multiplication, polar, much, much easier. If I have 20 angle 60 divided by 4 angle 30. You divide the two numbers in the front. What's 20 divided by 4? 5. What's 60 minus 30? 30 degrees. Divide, subtract. No conversion, nothing. Angle negative 60 divided by 5 angle 30. What's 10 divided by 5? 2. What's negative 60 minus 30? Negative 90. By the way, if you look at that, the negative 90, remember in polar, or complex numbers, this is the real portion, this is the imaginary. So if you have a vector that's 2 units long along this axis coming down, that's what that is. Isn't it? So can you write that as a complex number?
Negative 2j.
Yes, it's negative 2j. Because it's coming down, it's negative, it's on the j-axis. There's a few of them like this you'll see. You'll see me quickly just change them. Go, what'd you do there? And that is if I have 5 angle 0. Again, what is that? 5 angle 0? It's a vector in this direction. This is the real, that's the imaginary. So you can write that as what? Just 5. There is no imaginary portion. It's on the real axis. If I have 7 angle 90 degrees, that vector looks like this. It's in this direction.
7J.
Yep. That's 7j. If I have a vector 8 angle, doesn't matter, plus or minus 180. Where's that vector? That vector is right there, right? 8 units to the left. So that becomes what? Negative 8. That's why when I say you have a minus sign, it's really 180 degrees phase shift. It's going backward. And we did the negative j. We already did that one. That's a, negative 90 degrees or plus 270. When it's down this way, that's a negative j. The only thing I have, like in my mind, like nobody asked this, how come when you multiply these and add the angles, and when you divide these and subtract? Why? Why is that? Because when you write 3 angle 60, what that means really, it's 3 times e to the j 60. Does anyone remember Euler identity? Euler? It's called Euler, actually. It says e to the j theta is what? Cosine theta plus j sine theta. When you break this one down, isn't that 3 cosine 60 plus j 3 sine 60? So this actually, when you write 3 angle 60, is 3 e to the power of j 60. And when you multiply, what do? You multiply the coefficient, add the exponents. So when you go 5 angle 60 times 4 angle negative 30, what you have really is this one. We just don't write it that way. Oh, I didn't mean to do that. Where's my eraser? There we go again with erasers. This is e to the j what? Negative 30. So how do you multiply these? Like 3x to the third times 4x to the negative 5. You multiply these numbers, 5 times 4, which is 20, and you add your exponents, j 30, which is what? 20 angle 30 degrees. So that's why when you multiply and add the exponents. When you divide and subtract the exponents, because that angle 60 is equivalent to e to the j 60. Now, why am I interested in complex numbers? What do we care if it's complex or not? The first chapter, actually, we're going to be looking at in Circuits 2, is solving a problem that has like a sine or a cosine for a forcing function. All the problems we did last semester in Circuits 1, when we went to RLC circuits, your source was a DC source with a switch there. And we looked at the time when the switch opens or closes for that little short time, that capacitor or inductor became a source and powered the circuit. Now what happens when your source is not a DC source, it's a sine or a cosine? We're going to use a method called phasor. And that's the best way to solve it. That's the quickest way to solve it, for at least as of now. And what phasor is, there was a process for that. I'll shut the video because I just want to make sure this video on complex numbers only. I'll talk about it later.